Bismillahirrahmanirrahim. Welcome to the new session, the second session of this ETAB. We have started this 10-story building, and we have completed some assignments. For example, we have defined some materials. Similarly, we have defined some sections as well, and also load patterns we have decided. Now let's see about the section properties, that how we can change the section properties for a model. Let's suppose we have this beam 15 by 24. So if we modify and we see the section properties, so here we will see that this is the name of the beam. Suppose this is 15 by 24 inches. So the main name should be well recognized. Then the concrete strength, suppose if you use 3000 psi strength, so select that one. Then the section properties, the dimensions we have, so 15 by 24. Modify, so modify if you want to modify, so the here for the beam we will use 0.35 as per Building Code of Pakistan, and as per ACI 0.35. Similarly here 0.35. So this change here in properties, automatically it will be changed here. So this is the total area, then the effective area, and all the properties are changed accordingly. So we have to check this one as well. Now next come to the rebars details. Here we can see that this is the beam design, so select that one. The steel compressive strength we can check here. This is 40 KSI, so we will change it to 60 grade. Similarly the ties, the stirrups we will change to 60 grade. So top bars cover. So this is very important, that how much will be the cover to the longitudinal rebar at the top. The top we have 2.5 inches clear cover from the stirrup. So this is the top bars cover. So here we can put 2 inches. Similarly the bottom we can put here 2 inches. This is done, so make it OK. Then OK. So this is a change. If you want to add some new property, click here, and if we need rectangular, so click here, or if we need circular, we can select this one. So for rectangular concrete we can select this one. So this here we can put the name. Suppose we want to add a beam of cross section 12 inches by 18 inches. So this is the beam name. Then we select 3000 psi strength, like here. Rectangular, this is 12 by 18 inches. Just note that this 18 inches will be inclusive of slab. So the suspension will be 12 inches and the total depth will be 18 inches. So if we want to define some beam, so we must be clear about the suspended portion and the total depth. So the total depth will be considered as including slab, the total depth will be. Similarly modify my part. So here as per code put here 0.35, here 0.35, here 0.35. This is for crack sections. Rebar put here like we are selecting this beam. This is 2, this is 2, this 60, okay, so mark it, okay. Now let's see section properties. So this is the detail, just distribute. This is 216 12 by 18 inches, and this is the area of the section, correct one. This is modulus of elasticity, moment of inertia, and cylinders ratio. Similarly, all ratios are given here. So okay, so the name is already existing, so just make it 12 inches by 18 inches. Okay, so this is done. Now come to the another important property. In the load pattern, we select UBC 97. Why we select UBC 97? So we should be clear about this, that we, for the earthquake loads or lateral loads, we use UBC 97. If we click here, suppose if I click here, so a number of codes will be appeared. Okay, AC 710, AS 1170, Chinese code, then Euro code, Indian standards, Italian code, Chinese code, KBC, NBCC. So all these codes are international codes. So after this 2005 earthquake, Building Code of Pakistan has adopted UBC 97 as a code for the lateral loads. Let me show to you the starting page of Building Code of Pakistan. That suppose if I say UBC, so this is one of the function. So everywhere in the Building Code of Pakistan you will see UBC 97. Let's see the start at where the code start. Here. So here we see that after this 2005 earthquake, this is very important for each and every engineer who is going to design some building. He should be clear about the code and about the Building Code of Pakistan. Actually, in Pakistan we use we adopt this code. So according to Building Code of Pakistan, the seismic provisions are compatible with the Uniform Building Code 1997 of USA, the American Concrete Institute ACI 31805. So all these are compatible with the Building Code of Pakistan. So we have adopted all these codes. So for lateral loads we use all these codes, ACI 31805 and 1997. So we have to select this one code. So this is just for to show you that why we select for lateral loads this 1997. One important thing is that every year all these codes are updated, and in the new version of ETABS this 1997 is not available. So what we have to think, we have the Pakistan Engineering Council should think about this, that they must approach to the authority that to improve this UBC 1997, or they should incorporate all these things in the building code of Pakistan, as it is not being updated. How you can you can get this code, building code of Pakistan? So you have to you can get it from Pakistan Engineering Council. So this is PC website. Let's click here official documents. At the bottom you can see this is building code of Pakistan. Just click it. So you will have this, all these codes. So building code of Pakistan, seismic provision 2007 on the top. Building code of Pakistan in energy provision 2011. Similarly for electric, Pakistan electric telecommunication safety code, PITSEC 2014. Building code of Pakistan fire safety provision. So all these codes are available on PEC website. Every engineer can get it easily. All these are downloadable, can be downloaded easily. This is just to show you. So we select this UBC 97. If in the last lecture we have discussed that all these properties are very important for the engineers. We select here R as 8.5. Why we select this 8.5? Actually we have three types of buildings. Actually the moment resistant frames are three types. One is ordinary, and one is intermediate, the third is special moment resisting frame. So if suppose we assume that we will provide all the details according to special moment resistant frame, so we can put this R as 8.5 according to code. Where it is written in the code, let's see. Building code of Pakistan, suppose select moment special moment resisting frame. Special moment, let's see. Special moment frames, SMRF, special moment frames, CSMRF. So this is special moment. What is special moment resistant frame? Is a moment resistant frame specially detailed to provide ductile behavior and comply with the requirements given in chapter 7 and 8. So in chapter 7 and 8, all the requirements should be fulfilled according to this SMRF. So that frame will be SMRF if we fulfill all the requirements mentioned in the chapter 7 and 8. Similarly, this R factor is available in the table. Let's see. One thing is very important, that for zone 3 and 4, we have 5 zones in Pakistan, 1, 2A, 2B, 3 and 4. So for 3 and 4 we have put this SMRF frame structure. So here if we see this moment resisting frame system, special moment resisting frame SMRF, for steel this R should be 8.5, and for concrete this R should be 8.5. This is for SMRF. Okay, so let me share with you the title of this table. This is the lateral force resisting system description, basic structural systems. This is the R factor, R value. This is omega. So if we want to take the value of R, so we can choose from here. This is here SMRF, concrete 8.5. Okay, for IMRF, intermediate moment resistant frame, this should be 5.5, Similarly, OMRF, this is 3.5 per concrete. Okay, so 3.5 is for ordinary. Ordinary mean that no seismic detailing is required. Intermediate is that we if there is some provision that maybe some detailing is missed, or are not 100% that seismic provision are detailed in the drawings. So this is for the this is very important, that if we put here in the design 8.5, so according to this 8.5 R, we must we have to provide the design, the details in the drawing according to the requirements of chapter number 7 and 8. So like seismic hook, standard hooks, development length, left splice location length, all these are dependent on this R factor. Similarly, the connection requirements, spacing of ties, stirrups, all these are connected with this 8.5. So if we put 8.5, then we must provide in the drawings all the details required for this one. Okay, this is for the information. Similarly, the soil type, we have according to Building Code of Pakistan, we have types, 5-6 types. Let me share with you. Building Code of Pakistan is actually consists of almost I think it's 12 chapter. This is number 10. This is 11. Okay, so 11 chapter are there. In chapter number 4, I think. Yes, chapter number 4. The foundation details are given. So the designer must know about the Building Code of Pakistan chapters and the names, the details, that from where I can put this value. He must know about this one. So soils and foundation, chapter number 4. Symbols and notation, scope, determination of site condition, site geology and site characteristics, site profile types. So this 4.4 soil profile types, we must know soil profile types. Let's see the details. So we have soil profile types is A, is B, is C, is D, and is E. Okay, so these are tabulated in 4.1, and one is F, is determined soil requiring site specific evaluation. Soil profile types, let me share with you all these details. Let's suppose if we use SA type, so it must, if the soil is rock and it is very hard and the strength is too much heavy, too much tough, and the velocity speed should be greater than 1500 meter per second. We must know about it. The more the solid thing, the more speed of velocity will be. So if the velocity speed is more than 1500, then it's a rock, and we can mark it as SA type soil. Okay, so if we go to the ETABS, so here we can have SA type. If we suppose is B type, medium hard rock, this is rock but medium one. Okay, the speed of velocity is between 750 to 1500 meter in between the range. So this is a little bit porous than the first one. It is a rock but not too much solid. The third one is C, very dense soil. It is soil actually, not rock, but soft rock with 350 meter per second velocity to 750 meter. Then is D type, stiff soil with 175 meter per second. This is the range. So all these types are here. Also we can select the type of soil from the N number, SPT number. So these are soil types. Here is A hard rock, is B rock, is C very dense soil and soft rock. Okay, so the if the N number is PT number, standard penetration test number, this number is greater than 50, then we can mark as an SC soil. Okay, if this is between 15 to 50, then we can take this from the geotechnical report. So if a geotechnical report is available for the structure, then we can easily mark the site as SCR, STR, SE. Okay. So all these material we should know about all this, that how we select this type of soil. Then the zone. We have 5 zones as I already discussed it. Suppose 1, 2A, 2B, 3 and 4. So in Bildukona, Pakistan, again if we see here, so on the start of the code you will see a map, and all Pakistan has been divided in 5 zones. Okay, so it's written here Tehsil seismic zone, Tehsil seismic zone, all distributed. Suppose if I want to choose Peshawar, so just write Peshawar, you will get the code. So Peshawar is 2B. Okay, Shangla, Alpuri, this is Shangla, so this is a Swat area, this is in 3 zone. Bisham, Chakesar, number 2. So, like Kuhat, similarly, Landi Kotal in 3, like Bada 2B, Jamrod 2B. So we have to consider, because the zone is very important. If we mark the zone as 3 instead of 2, so the detailing will be changed. If we mark it as a 2B instead of 3, so the details will be changed and the calculation will be changed. So this is very important that we have to select the proper zone from the map. This is from Bildukona, Pakistan. We can select it. Here all the direction in eccentricity, we want earthquake maybe in 2 directions. Okay, or in the horizontal direction or in the vertical direction. So we have to define, we have to check the structure for both the direction, horizontally as well as vertically. For horizontally we should mark all these. Okay, x direction plus eccentricity, that x direction plus eccentricity is available. X direction plus minus eccentricity, it means that here is a plus eccentricity, is minus eccentricity. So we have to consider all these combination. So the combination of loads will be taken in the x direction if we choose it. This is the if we can select the stories after which story we want to design, 12 story base one. Importance factor is another important value we have to choose. Why this is important? Some buildings are very important, like atomic energy buildings, hospitals, water tanks, like some police department, police stations, army buildings, or like marine structures. So these are very important. So this importance factor will increase your sections and your structure. If we increase this 1 to 1.25 or 1.5, so the structural behavior will be changed. That this is very more important, so we have to take care of the things like the column section will be changed, the beam section will be changed. So you can check it from Bildukona, Pakistan. Suppose important importance factor. Importance factor, this is occupancy. Let me share with you the table. This is the table. This is a building code of exam chapter number 5, occupancy and category. So we have different categories, essential facilities. These we have to check all these. That if my building is related to all these, like division occupancies having surgery and emergency treatment areas like hospitals, is fire and police stations. So we have to take this. Garages and shelters for emergency vehicles and emergency aircraft. So this is for the during the war, and we have to take care of all these buildings because we need in emergency. Structure and shelter in emergency preparedness centers, like in earthquake or like flood or glaciers. All these buildings should be compatible with all these active forces. Aviation control structure and equipment in government communication center and other facilities required for emergency response. So for this importance factor is 1.25. If we are designing these buildings, so we will put here 1.25. If we are designing these buildings, so it will be 1.25. But if we design these buildings, this is 1. Okay. One is that in normal that importance is there, but not too much as compared to the other 1 and 2. Like buildings housing group E division 1 and 3 occupancy with a capacity greater than 300 students. Buildings housing group B occupancy used for the colleges or adult education with a capacity greater than 500 students. So the educational institutions, hostels, school, colleges, universities, we can put this 1. All these we can check here just to show you the importance. Okay, so make it okay, done. Okay, done. Now let's see the other important factor we have to choose very carefully is the load cases. So these automatically it will be brought here, no need to change. Okay, so all these are the properties we have to choose very carefully, and we have to assign all these. Now let's come for the assignment of the columns. If we define all the columns, beams, and all the properties, material, so now the model is ready, we will go to the assignment. But for this we have to check the drawings, that the drawings according to our drawing, what is on the basement floor, the lower basement floor, what is on there. So we have to choose the column size according to that. We have to see the number of stories, the requirements of the structure. If there is a car parking, so we have to choose the beam section accordingly. This is all these things are dependent on experience as well. That if someone want to design something, he must know and he must observe all the buildings, that how I can choose the section. That if I choose a section and its formwork is not available in the market, so it will be a problem. So the designer must think and must keep in mind that I have to choose a section for which the formwork is available and which can easily be provided on the site. Okay, so let's start marking of the columns. We will start from here column. This is the shortest way, that if I suppose I select the column property, select here from here, I start from 30 by 30 column, okay, and I want to use 3000 KSI strength. This is 36 by 30. Let's see 30 by 30. This is okay. It's continuous, and let's see. Now I have to put the columns carefully on the grid date, for which I have defined this grid system. So the first column will come on the this corner. As you know that this exterior grid is for the balcony or for the shade. Okay, so the first column will come, and this other grid is for the balcony and for the shade. So another column here. Okay, two columns. Just let me share with you that this is one story, that all this column will be applied to the one story only. Okay, so let's assume, let's change it, remove this one and select this as a all stories, and then again select here columns. Okay, so now okay, so all these columns are in one parallel line. Then in the other one, here we have this one grid, then this one grid. Okay, so one line is connected. Just see the 3D. So these columns are up to the top. Okay, 2D. Then we have to select this one. This one, this one, this one, and this one. Okay, and then other one here, 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 and here. Okay, the third one, fourth one, here, 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 and here. Okay, so the last grid is not horizontally regular, and it is in the slope. So we have to check that how we will connect this last one, and these small grids I have defined for the slope one, as I have shown to you last time. Let me share with you the drawings that these are the drawings. See, so if we see, the drawings are in slope. So this grid line is in slope. So up to this we have marked. Now we will mark this one. So we will say it like this. Okay, so this is the last grid, last one we have to select. Okay, here, okay, here. So this is almost this. Okay, this is like this. So all the columns are marked, and let's see in 3D. So let me check the relation. See the 3D. Okay, this is grade G from bottom to top. Okay. So we have marked all the columns. Now the next step is that we will mark the beams. So we have to choose the proper section, which beam we have to select. For this we have to go to the plane. Okay, so let's suppose we have to go to the foundation. Here we will have raft. This is actually 10 stories, so it will raft automatically. So all these columns will be connected in the raft. Okay, just provide a beam here to connect all this column, that this raft will help us to reduce our lateral forces and will reduce the demand as well. So will be very good if we provide the beam on the bottom floor as well. So this is the bottom floor, the plinth level. Okay, below this we will have this foundation. This is 5 feet at the top of up to 5 feet. This at the height of 5 feet, like suppose, and we will mark this foundation connection as a fixed one, because for the raft we will select fixed one support. Okay, I think for today it's okay. It's enough for today, and inshallah in the next session, inshallah we will continue this design, and keep with us, inshallah. We will inshallah learn, and we will design all this building, inshallah. Thank you so much for watching this. Allah Hafiz.